Hello everyone. In this video, we will see what volumetric measurement is and how to do a volumetric survey in the Surveyaan Geoworkspace. So, now let us see what a volumetric measurement is. Volumetric measurements are used to calculate the volume of the stockpiles and other materials. It has two surveying techniques, ground and aerial survey. As you can see on the figure, here the ground survey is done on the ground using the total station or the DGPS. And the aerial survey is done using the drones. There are several advantages of aerial survey over the traditional ground survey. When the traditional ground methods are used, the surveyors have to take points in risky areas of the field. While in aerial survey, it is easy to take points from inaccessible places. For example, if you have to take points at the edge of a cliff or a slope of a stockpile, then it is high risk for the person. Whereas the drones can be flown over and photos can be taken. So there is no human risk. And another point is the drone generates millions of points compared to the hundreds gathered in a ground based survey. These points are very important to develop the final map. Since they generate billions of points, the volume calculated using aerial survey is more accurate than the traditional ground survey. And the last and the most obvious point is that the aerial survey is 10 times faster than the ground survey and is fast and also reduces the time the surveyors spend on the ground. Now we know the advantages of aerial survey and let us understand how aerial survey is done and how the volume is estimated using the aerial survey. The first step is the data acquisition. Here we go to the field and then plan the flight and mark the GCPs and fly the drone and collect the images. The second step is the data processing. We use the images that we got from the drone and process it in a photogrammetry software to get these outputs. The outputs are the digital elevation model, point cloud, and the 3D model. And the final step is the volume estimation. And we have many methods to calculate the volume. And some of them are mentioned here. They are the lowest point, linear fit, compare done, and the manual baseline method. And we will discuss all this in the later part of the video. Since now we know about the workflow, we need to know some important terms that are discussed in the volumetric measurement. So let us see them one by one. The first one is the digital elevation model. Before that, I will tell you why we need the digital elevation model. The volumetric measurements are done using the digital terrain model and the digital surface models. The software calculates the volume from these models. And let us see what the digital elevation model is. The digital elevation model is a 3D representation of the terrain elevation on the Earth's surface. The digital terrain model and the digital surface model are derived from the digital elevation model. The digital surface model represents the Earth's surface, including all the objects like the trees, buildings, and here you can see in the image these rounded structures. They are actually the trees. Next, let us look at what the digital terrain model is. The digital terrain model consists of the Earth's surface, but it does not include the objects like the trees, buildings. It only contains the terrain. And here in this picture, you can see that there is no rounded structures like the one in the digital surface model. And this is how you distinguish a digital terrain model from the digital surface model. In the volumetric measurements, usually the digital terrain model are taken because it gives us the accurate volume measurements as it does not involve the elevation of the trees, buildings. Whereas the digital surface model, since it contains the object, we get inaccurate measurements. While we move forward, I will be using these terms frequently. So let us know them beforehand. Here, the cut is the portion above the base plane. For example, in this image, this is a stockpile, and here the stockpile is on the upper surface of the plane. So the volume calculated here will be the cut volume, and below this will be the fill volume. Next, we look at what a fill is. The fill is the portion below the base plane. And here in this image, this portion, this is a pit-like terrain, and we have to calculate the volume of this portion. So here, the volume calculated will be the fill volume, and above this will be the cut volume. Now we know about the cut and fill. While measuring the volume, we also need to know the different types of base plane. Here, I have the lowest point and the linear fit method. In the image, the first one is the lowest point, and as you can see here, there is a stockpile, and the polygon is marked around the stockpile, and the polygon is marked with numbers. The dotted lines denote the base plane, and this is derived from the points 3 and 4. And here, the base plane is a horizontal plane. In lowest point method, the volume is calculated in a way that from the marked polygon, the lowest point in the polygon is taken and a base plane is created from that point. Here 3 and 4 have the lowest points. The volume above the base plane is the cut and below will be the fill. And the lowest point method is generally used when the stockpile or the earth is on a flat ground. Next, we have the linear fit. And as you can see, the base plane, that is the dotted lines here, are not straight but in a linear way. Here, the base plane will be in such a way that the plane that fits the best will be used for calculating the volume. And generally, the linear fit is used when the ground underneath the stockpile or the earth is sloped. We also have another method called the manual base plane. And in this method, we select the base plane manually. Initially, we need to know the base elevation of an area. If we have the known base elevation, then we can enter that and get the volume measurement. Here, the base plane will be selected on the elevation we have inputted, and the base plane would be a horizontal plane. Next, I will show you how to calculate the different volume types in the Surveyaan Geoworkspace. So this is the project result, and on the left is the 3D map, and to the right is the 2D map of the same project. Let me zoom in the maps. And here you can see that this area is actually a pit. Now let us find the volume of an area. First we need to mark the volume, and here the first method is the lowest point. And here, since I have marked this area, and consider this is the lowest point, and from this point a base plane is created to calculate the volume, and the area above this plane is the cut volume, and the area below will be the fill volume. And here you can see that the cut volume is more. This is the area that I have marked in the 2D map. And here we can see that the cut volume is more. And the next method is the linear fit method. And now if I extend this area, and here I am changing it to the linear fit method, then the base plane will be in such a way that the plane will be in a linear shape. And here the plane that fits the best will be used for calculating the volume. Here, this is the portion that have been marked on the 2D map. Here the fill volume is more because it is on a slope, and the area below the base plane is the fill volume here. Now moving on to the next method is the manual base plane method. Here we can select the plane manually. We need to know the base elevation, and with that known point we can enter it here and get the volume measurement. And since I know the elevation, I am inputting the elevation here, and then I give calculate, and here I get the volume measurement. We also have another type of survey conducted periodically, and this is the volumetric survey. And in volumetric survey, usually a site is surveyed first, and after working on the site for 1 month, then the site is surveyed again. Then both the results are compared to know the change in volume of the work done. With this method, we can compare similar projects done at the same place in different time frames. Here in this figure, to the left is the result of the project that has been surveyed first, and to the right is the same project surveyed after 1 month. The elevation profiles are given in the photos, and here, while seeing the profile, you can see that the image to the left is having a higher elevation than the second. This means that this area has been dug up, and so there is a change in elevation. Now I will show you both the projects in the 3D view. So this is the 3D model of the project that has been surveyed after 1 month. And this is the 3D model of the same project surveyed first. And here you may be wondering why this project has got this much light. So I will give you advice to fly the drones when there is less sunlight. So while we compare these 3D models, here we can see that this area is flat, and after 1 month, this area has been dug up, and now this area has been transformed into a pit. And now I will show you how to calculate this area using the volumetric survey. For that, I have the 3D and 2D view of the same projects. To find the volume using the volumetric survey, first select the area. Here I am marking the area. This is the area we are selecting, and then select the compare dump method. And from the select project list field, click on the project surveyed first, and it will automatically calculate the volume. And here you can see that this is a pit, and all the points that I have selected are inside the pit. And here the volume above this will be the cut volume, and below this marked area is the fill volume. And here you can see that the cut volume is more here, and this is how we calculate the volume using the compare dump method. So this brings to the end of the video, and I hope you have gained some knowledge on volumetric measurements and the different volume type. And to freshen up, we will have a quick recap. First, we discussed the types of survey, and we saw the elevation models, and then the cut and fill, and finally the different types of volume measurements. And if you're watching this video for the first time, please like and subscribe. And for all the GIS enthusiasts out there, we will be sharing more videos weekly. Click on the bell icon so that you won't miss any of the upcoming videos. So thank you for watching the video.